The Milky Way story is far from over. In about 4.5 billion years, it will collide and merge with the approaching Andromeda galaxy. Despite the dramatic scale of this event, the vast distances between stars make direct stellar collisions unlikely. Instead, gravitational forces will reshape both galaxies, flinging stars into new orbits and forming a massive elliptical galaxy known as Milkomeda. As this new structure stabilizes, the Milky Way's identity will vanish. But even greater changes lie ahead. Due to dark energy, the universe's expansion will continue accelerating, eventually pushing all unbound galaxies beyond the observable horizon. In the far future, Milkomeda will be alone, gravitationally isolated and surrounded by darkness. Its stars will age, fade, and die, leaving only dim remnants to orbit silently. Will intelligent observers of the distant future ever know that other galaxies once existed? Or will cosmic memory vanish with the light that can no longer reach them? True or false? Most stars in the Milky Way, including the Sun, are expected to survive the merger with Andromeda. True. What will the Milky Way become after merging with the Andromeda galaxy? A giant elliptical galaxy. Fill in the blank. The Milky Way and Andromeda are currently approaching each other at a speed of about blank. (110 kilometers per second). Fill in the blank. The galaxy formed from the Milky Way-Andromeda merger is often called blank. Milkomeda. Why won't most stars collide during the Milky Way-Andromeda merger? The distance between stars is extremely large. Fill in the blank. The Sun may be displaced to a new orbit due to complex blank interactions during the collision. Gravitational. True or false? The Milky Way and Andromeda will collide in less than 1 billion years. False. The collision is expected to occur in approximately 4.5 billion years, not within the next billion. Fill in the blank. Distant galaxies will eventually become invisible as they cross the cosmic blank. Event horizon. What force causes galaxies beyond Milkomeda to disappear from view in the distant future? Dark energy. Fill in the blank. Milkomeda will become gravitationally blank from all other galaxies in the far future. Isolated. True or false? The universe's accelerating expansion will eventually isolate the Milky Way from the rest of the cosmos. True. Fill in the blank. The supermassive black holes at the centers of the Milky Way and Andromeda will eventually blank. Merge. What is the expected fate of the Milky Way's supermassive black hole after the merger? It will merge with Andromeda's black hole. Fill in the blank. After trillions of years, the galaxy will be populated mostly by stellar blank. Remnants. Fill in the blank. In the distant future, observers in Milkomeda may falsely conclude that the universe is blank. Static and unchanging. What will the universe look like to intelligent observers living in Milkomeda trillions of years from now? And how will their understanding of cosmology differ from ours? Observers in Milkomeda trillions of years from now will see a vastly different cosmos. Due to dark energy, all galaxies not gravitationally bound to Milkomeda will have long since crossed the cosmic event horizon. To these future astronomers, the night sky will be devoid of other galaxies, and they may believe their galaxy is the entire universe. The cosmic microwave background will have redshifted beyond detectability, and gravitational wave remnants from past mergers may be too faint to observe. As a result, they will have no evidence of the Big Bang, cosmic expansion, or large-scale structure. Their view of the universe could be entirely local, static, and misleading unless future technology or theoretical breakthroughs allow them to reconstruct cosmology from within an isolated island galaxy. True or false? In the distant future, the Milky Way's merger remnants will be the only gravitationally bound structure visible from Earth. True. What will happen to the night sky as Andromeda approaches the Milky Way? It will appear larger and brighter, eventually dominating the sky. Fill in the blank. After the merger, the Milky Way and Andromeda's galactic disks will be blank into a new structure. Randomize. Andromeda is currently 2.5 million light-years away and approaching at 110 kilometers/s. How long until it collides with the Milky Way? If Andromeda is 2.5 million light-years away and moving toward us at 110 kilometers per second, we first convert light-years to kilometers. 2.5 times 10 to the 6 light-years multiplied by 9.461 times 10 to the 12 gives us 2.365 times 10 to the 19 kilometers. We divide that by 110 to get 2.15 times 10 to the 17 seconds. Finally, dividing by 3.154 times 10 to the 7 seconds per year gives us approximately 6.8 billion years until the collision. What primary factor allows Milkomeda to remain visible while other galaxies vanish? It's gravitational binding within the local group. If the Sun is flung into a new orbit during the merger and moves at 220 kilometers per second for 10 million years, how far will it travel? If the Sun moves at 220 kilometers per second for 10 million years, we start by converting years to seconds. 10 to the 7 years multiplied by 3.154 times 10 to the 7 seconds per year equals 3.154 times 10 to the 14 seconds. Multiplying that by the speed gives us a total distance of 6.94 times 10 to the 16 kilometers. True or false? Galactic collisions always lead to chaotic destruction of most stars. False. Despite dramatic gravitational effects, stars rarely collide during galactic mergers due to the immense distances between them. Fill in the blank. In a few billion years, Andromeda will appear blank in the night sky. Brighter and larger than the Moon. What long-term fate awaits most stars in Milkomeda? They will evolve into stellar remnants like white dwarfs and neutron stars. Fill in the blank. The local group will evolve into a single galaxy due to blank attraction. Gravitational. true or false. Eventually, the local group of galaxies will merge into a single, massive structure. True. The Milky Way, Andromeda, and other nearby galaxies will merge due to mutual gravitational attraction, forming a large elliptical galaxy over time. Fill in the blank. As the universe expands, galaxies not bound to the local group will cross the cosmic blank. Event horizon. Why might future civilizations be unable to learn about the universe's expansion? Because all cosmic signals from outside will be undetectable. A distant galaxy moves beyond the event horizon by crossing 4 times 10 to the 9 light years in 2 times 10 to the 9 years. What is its average recession speed? A galaxy moves 4 times 10 to the 9 light years in 2 times 10 to the 9 years. Dividing gives us 2 light years per year. To convert that to kilometers per second, we divide 9.461 times 10 to the 12 kilometers by 3.154 times 10 to the 7 seconds, which gives about 300,000 kilometers per second per light year. Multiply by 2, and the galaxy's recession speed is 600,000 kilometers per second. How did you do? Tell us in the comments below. And thanks for watching BrainyKidz. We hope you had fun learning today. Don't forget to like, subscribe, and hit the bell so you never miss a new quiz. See you next time, Brainy friends.